Hi, everyone. We are late because I have a stupid allergy.
It
Iron-
really is.
yeah, so ironically, I was tweeting about this yesterday because it's a super annoying allergy. I have a latex allergy. This is a progressive allergy. Anyone out there can get it, where one day your body is like, F you, no more natural rubber related products for you. So, like, I am forever discovering things that I'm allergic to. And because this is a progressive allergy, every interaction I have with the latex product makes the allergy worse. And I'm not to be trusted prior to coffee, as anyone who has spent time with me in real life knows. More than one person has approached me in the day and said, "Here is coffee, drink some, and then I will talk to you." So apparently, prior to coffee, I brushed my hair, braided it, and without thinking, grabbed the nearest hair tie and put it in my hair. And I was sitting in my chair trying to figure out why I had that feeling you get when you know if you would cough, it would clear your lungs, but you're not sure you would ever stop coughing again. So you don't cough and just breathe really shallow.
Uh, yeah.
And I just kind of was feeling terrible. And I just happened to reach back, pull my braid around, and realize, shit, hair elastic I'm allergic to. So my braid, of course, had gotten under my clothing, and I'd been leaning against it in my chair. And so the back of my back, that's, I guess, a word, was itchy. And I was like, okay, I'm just going to have to go take a shower now. I'm feeling better now. I am irritated. And I'm mostly irritated because this is 100% preventable. If someone had told me both my mother and grandmother weren't just weirdly allergic to certain things, but that this was a cluster of things all related to latex and rubber, and
Right.
that I could have avoided this allergy by never buying cheap shoes made of artificial leather, by avoiding cheap elastics made out of natural rubber.
Yeah.
If I had known, I would have made very different life choices.
So for those of you who are just like setting off in life without a latex allergy, this too can catch up with you. Yeah, my stepmother had a latex allergy, and it was rough having to avoid all kinds of anything. It's everywhere,
Yeah,
in everything.
yeah.
Yeah, yeah, yeah. It's brutal. Okay. Are you ready?
No, but we're going to pretend.
You have your coffee though, right?
I do. This is coffee number two.
Okay, good, good.
Let me adjust my lighting just a second because I turned on the lights and then things.
Did you hear that YouTube is offering podcasters $50,000 to set up a environment on YouTube and start video streaming their podcasts?
No, tell me more.
Yeah, that's it. That's all I know. If you do a search, I'm sure you'll find more about this information. But yeah, yeah. So you know what we should do? We should consider like broadcasting our podcast on YouTube and maybe Twitch too at the same time.
Yeah, yeah. I mean, who would have thunk that that was a good idea?
No, I can't even think of anyone who would have thought that that was a good idea to do 10 years ago. Um, yeah, yeah. So now I got to figure out how do we get into that program?
Yeah, yeah, especially I'm just worried that this is going to be like here in the US with COVID, they did a whole lot of get $100 if you get vaccinated. And I was like, "But I'm already vaccinated." And they're like, "No money for you."
Yeah, no money for you. No, this is for the people. Yeah, yeah, yeah.
So
But
I
maybe we could apply for a grant to
yeah.
improve our capability. I don't know. produce additional material just on the YouTube, or I don't know.
I will look into it. I now apparently know how I'm spending my afternoon. Budgets.
Yeah. I don't. Yeah, I don't have. I wasn't able to find any kind of connections on behind the scenes. Like it sounds like they've been reaching out to existing podcasts. So
Okay.
we didn't get the call, but that doesn't mean that we can't necessarily
Yeah.
chip in. So yeah.
All right. I will check into that.
Yeah.
All right. So I knew
ready?
my audio. I'm working on it. There it is. Today is 6:33?
4.
4. Those numbers just keep going up every time.
It's funny how that works. All right.
All right. Here we go. I'm
ready?
pressing record. I am
I've also
pressing
pressed
the
record.
other record. We are recording. The levels look okay enough.
Okay. Here we go. Astronomy Cast, episode 634, Milky Way, Mergers and Acquisitions. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm having an allergy day. So if I look a little bedraggled, it's because I have a latex allergy. I tweeted all about this yesterday, and then today made a hair elastic mistake.
Yep.
So the red eyes that are tearing up have nothing to do with anything in the world and everything to do with one lone misbegotten hair elastic.
I also have red eyes that are tearing up, and mine just seasonal allergies and a little congestion in my nose. I sound a little congested, but welcome to springtime in the Northern Hemisphere.
Yes.
The Milky Way is a vast, grand spiral today, but how did it get this way? Astronomers are starting to unravel the history of our galaxy, revealing the ancient collisions with dwarf galaxies and how they came together to build the modern Milky Way. And we'll get into this in a second, but it's time for a break. And we're back. All right, Pamela. How can we do this episode and not just have me ranting and enthusiastically praising the Gaia space mission?
Well, we can talk about the fact that, like, mergers aren't just in the Milky Way, and
they happen at other places too.
And the ARP catalog of irregular galaxies. And
all right. But there's going to be a lot of time
dark matterless galaxies.
Sure. Yeah, but there's going to be a lot of time spent praising Gaia.
Gaia is amazing.
Yeah, just be prepared. Just be sort of emotionally equipped to handle the effuse praise for the Gaia mission. All right. So I guess, where did astronomers think galaxies came from?
So originally, they didn't. We for a long time thought that the galaxies that we were seeing out there were just nebula. They're not.
Right, of course, yeah.
But once we started to figure out that there are these other island universes out there that are full of stars and have myriad different structures, two different ideas came about. And at that point in the history of astronomy, we believed it was an either or, not an and. And the explanations were that it was either what we call top down or bottom up, where either a whole bunch of mass came together, merged, formed stars, and a galaxy was born out of whole cloth, like Athena coming out of the skull of Zeus.
Right. Just one big collapse, broke it up into little pieces, stars formed, and galaxy done.
Yes.
Bigger or smaller, just depending on how much material they had to work with.
Exactly.
Right.
Then the other idea was you only form small things. You only form star clusters, dwarf galaxies, that's it, little things. And over time, those come together, merge some more, and bigger and bigger and bigger systems are able to form. now we understand it's a both things
Hmm.
appear to happen, but that's one of the cool things about modern astronomy is we're realizing all these things where people got into raging arguments of no, it is only top down, no, it is
Right.
only bottom up. It's both people, it's
Yeah.
both.
And I mean, we are like a little ahead of the gun in that one of James Webb's primary jobs is to be able to peer out into the early universe and ideally see these processes happening
Yes.
directly, to actually image the smaller structures as they came together. So with like a year from now, we will be able to give you a much better answer about how this works. But the thanks to the Gaia mission and all our observations of other galaxies, we still see these merger processes, these collisions happening both in the Milky Way and around us.
Yes. And what I'm loving is impatient astronomers got super creative in finding ways to do the science JWST is designed to do using much more complicated processes, but they still got there and were able to image that at the very beginnings of the universe, the first galaxies we're seeing have among them giant galaxies. And yet, as we look around our current universe at the things nearest to us, including ourselves, we see little galaxies constantly merging into bigger systems,
Hmm.
mid-sized galaxies, small galaxies, all colliding. It is galaxy hits galaxy all the way down.
It is interesting that it is still like it just continues to be this bit of a paradox. Like every time Hubble finds a more distant galaxy, the gist of the article is like this galaxy is far more mature and complete than astronomers ever thought they should see.
Yes.
And then at the same time, there are dozens of dwarf galaxies buzzing around the Milky Way, all of which are doomed. Um, a collision is due for us with Andromeda. That we see galaxy collisions and mergers all around us, and so I don't know. It sort of feels obvious now that it is both. They got big quick, but also they got
Yeah.
finished off with lots of other smaller mergers.
And this idea that things evolve differently in different environments is it's actually part of what I was studying with my dissertation. It's
Yeah.
a project that is still getting worked on today where we are understanding that the largest things that whether it be the largest stars or the largest individual galaxies, they just collapsed first. Gravity collapsed them down quickly. And in these larger gravitational fields, you end up with the environment getting pulled in more effectively, creating higher dense clusters. In these higher dense environments, you have more chances for things to fly past each other, to directly collide together. This evolves things faster, both stripping out dust, triggering star formation, leading to these massive, fully evolved clusters. But when you look at small groups of galaxies like the one we live in, our own local group, you don't have as much mass. And things are moving slower. Things aren't interacting as much because there's just not as much to interact. And this allows star formation to just slowly chew forward without these massive bursts of star formation. It allows the smaller galaxies time to get consumed. It allows the larger galaxies time to evolve and then fall into one another.
All right.
It's go ahead.
Oh, I was going to say, we're going to talk about this some more in a second, but it's time for another break. And we're back. So, with the launch of the Gaia spacecraft, and this is the European Space Agency's finest astrometry machine, which
It's
is
amazing.
giving us, it's amazing, which is giving us the location of 2 billion stars, the motion of them, we're learning a tremendous amount just about how the various stars are moving around inside the Milky Way. And how has this cast a lot of light on how the Milky Way grew?
I don't know if you even meant to pun, but it was brilliant. Uh, cast light.
Okay, right.
Uh, so what's amazing is it's not just the positions. They're also getting high caliber photometry and hints at the chemistry of these stars. And
Yeah.
this allows them to get at these groups of stars moving on similar orbits with similar ages and similar compositions must have all come in through one giant galaxy eats galaxy event or one small one. And we're starting to get direct evidence of things that we had only modeled before. The idea that our Milky Way has a variety of different components. There's the main high density part of the disk. There's the thick disk, which is lower density, where stars tend to have more tilty orbits, for lack of a better phrase. There's that spheroid that goes around the entire system. And we said that the thick disk was likely due to collisions with other systems. And now we can look and say, yes, this specific set of stars going in this specific set of orbits in the thick disk, yes, those came from a merger.
And you can see some of the pictures that are associated with these research papers where they'll have like almost like a 3D image of the Milky Way, and they're showing you the stars that they've identified as one of these ancient dwarf galaxies that have been torn apart. What would that process have been like from, if you could sort of see a sped up time and from the perspective of either the Milky Way or the dwarf galaxy? What would happen?
Well, as the dwarf galaxy comes in, and my favorite of these, simply because it has the most ludicrous name, is the Gaia Enceladus sausage galaxy. It is.
Yeah, I don't approve. I don't like the name.
I both hate
I like
it and
weird
love
names,
it.
but I don't like it. Yeah, I don't know why. I feel like it just doesn't do it justice.
It's
Sausage.
true. It's true.
Yeah.
But it's still delightful. So as what was probably a once fairly spherical group of stars got too close to the gravitational field of the Milky Way, it would have started to experience what we call tidal forces. This is where the far side of the galaxy and the near side of the galaxy are getting pulled on so differently that it elongates the system. This is the same way our oceans essentially get elongated by the moon's gravitational pull. Except when it's a galaxy of stars, it just keeps spreading and spreading. Now, as it got closer, it in this case appears to have been pulled into a tight and tighter orbit. And the stars at different distances from the center of the galaxy would have not only experienced different gravitational pulls that elongated the system, but then over time, the different kinds of orbits would have different orbital speeds. So that further changes how the stars are spread out. So we can actually essentially wind backwards the process to see how the stars came in, how, depending on where they were in that initial system, they ended up in different kinds of orbits. And it's just kind of amazing. It's like being able to unstir ink in a substance. And there are substances you can do that with. And there are computer models you can, well, unstir the galaxy with.
Right. Yeah. Yeah. And like how many of those mergers do we think have happened?
So one of my favorite sports, and I've brought this up probably every year for the past several years, is every winter American Astronomical Society meeting since the 2000s, they have come out with another one too many dwarf galaxies that have been discovered as streams of stars. So we are getting into the tens, it looks like. And
Mhm.
while it doesn't seem like a lot, when you realize researchers are teasing apart individual stars, composition by composition, this is like looking at the population in the United States and rewinding immigration using genetics. They are essentially working out the genetic history of our
Yeah.
galaxy through chemistry.
Or like languages. Like that's one that is really cool. Like you take a modern language and
Yes.
then you can work back through the differences and the similarities to other languages, the family tree of languages all the way back to various mother tongues spoken in various regions. It's painstaking work, but at least it's possible now thanks to
Right.
Gaia. Did I mention Gaia? Yeah, thanks Gaia.
Yeah.
Um, but this how long ago did the last one of these mergers likely happen?
They're still happening. And that's the thing we have to remember is at any given billion years, a new galaxy could wander close enough to be consumed. And one of the ongoing is it, isn't it conversations happening in the literature is, are the small and large Magellanic Clouds on escape velocities, or are they eventually going to get consumed into our galaxy? So these two little blobs of irregular starry and gassy goodness could, if they're going slow enough and we're still trying to figure these things out, they could eventually become just a new stream of stars thickening the disk of the Milky Way.
But the big event is coming in a few billion years when we collide with Andromeda.
And in that case, it's going to be a whole lot more than thickening the thick disk. It's going to be one of these merger events where Andromeda is bigger than we are, but only by about 30%, according to some estimates. And that kind of a merger leaves none of the structures we see today existing the way they exist today. We're going to have the two systems collide, pass through each other, and then, like a damped oscillator, eventually settle into a new configuration that will likely be a more elliptical shaped galaxy. In all likelihood, there will be an active galactic nuclei phase where one or both of the supermassive black holes feed on gas and dust that is sent into the core. There's going to be masses of star formation. And these kinds of dramatic events we can actually study frame by frame by looking all across the sky at a bunch of different merging galaxies. This is something that Halton Arp did when he put together his catalog of irregular galaxies, which was a series of glass plate images of systems that looked more and more like dead bugs on your windshield than like spiral galaxies. And these are all the results of systems in different ways coming together with their disks at different angles, with their rotations different to each other, with their masses at different ratios. And we have gotten really good in the past 2 decades of advancing software technology to recreate all these different shapes in software.
Huh. So it's funny. So like he built this catalog of
Yeah.
weird irregular galaxies that he didn't have any explanation for. And now as you look at them all, they're all the result of collisions. And each
Yes.
one can be explained in different ways. Yeah, absolutely
Yes.
fascinating. I'm sure he would love to have heard what was uncovered about his work. All right, we're going to talk about this some more, but it's time for another break. And we're back. So what impact have these mergers with other dwarf galaxies had on the Milky Way? How has our galaxy been changed thanks to all of this additional accumulated material?
One of my favorite ways, and everyone's going to answer this question with their own favorite thing, I suspect,
Yeah, I have
is
mine.
we have what used to be called the Oosterhoff type 1 and type 2 globular clusters. And these are sets of globular clusters that are orbiting in different directions and have different compositions. And the stars in both types of clusters are ancient. And now we are understanding these to be the results of globular clusters getting stolen from incoming smaller galaxies, everything merging together to form our Milky Way. But some of those suckers had a different composition and just came in backwards.
And so the orbits of the globular clusters match the direction, the velocity that the original galaxy came in on.
Yes. Yes.
And so some are orbiting in one direction and others are orbiting in the completely opposite direction. It's funny. I actually did an interview earlier this morning with an expert in galactic morphology and evolution and stellar motion and I asked her, like, where do globular clusters come from? And she's like, we still don't know.
We stole some,
but they don't know, like, how they formed. Like, why are globular clusters?
Yeah.
And she's like, we still don't know. Like they are ancient. They are as old as the universe itself.
But we occasionally see them forming in other systems, and this is what screws us up.
Yeah. So mine, you mentioned the thing that you like the best. The thing that I like the best is that the Milky Way is warped. That we have a warp in the galaxy. This is something that was teased out, I think, of Gaia data by some Chinese astronomers in the last couple of years, that there is if you could see the Milky Way from the side, it would have a pretty significant distortion.
Yeah.
And that's because these mergers aren't perfect. They're messy. And each, some fairly large merger that happened in the past would have thrown a kick into the actual galaxy's disk shape and cause this warping, which is incredibly tricky to figure out when you consider the fact that we are inside the Milky Way. It's the analogy I always use is like, figure out, what your house looks like from inside your house, right? And the only way you could do that is like look at like reflected cars as they drive by to give you hints and glimpses of what your house looks like. And it's not easy. And the glass is distorting the shape, and yet you're trying to figure out the color and the shape and the number of windows and the door
and there are
patterns
walls blocking your view in different places.
Yeah, exactly. Yeah. And so it's tricky. What else do you think are some of the implications for the Milky Way because of the mergers?
Well, what deeply amuses me is we have been working so hard to come up with a unified model for, if you see this, then you have this much dark matter that is related to the distribution of motions in the spheroid of the galaxy. And then a few years ago, we suddenly discovered there's a few galaxies out there that don't appear to have dark matter. And so that was one of these, wait, how does that happen? And recent models have shown that if you have interacting systems that interact just right, as they pass through each other, one of them will end up essentially dark matterless as the dark matter gets stripped out of the system. And so while we in bulk can say most of the time when you have these kinds of things coming together, you end up with a galaxy with this ratio of light to dark. But as we look out at all of these dwarf galaxies, we see that some of the dwarf galaxies have massive amounts of dark matter. Some of them have very little, and all of this comes down to the interaction history of our galaxy. And we are either stealing dark matter or stealing luminous matter, and that is an interesting twist that we hadn't imagined a few years ago.
Yeah, it's, again, like the ability to map out the dark matter locations, the quantities, the densities of it around various galaxies. That science has progressed significantly now, so that we have very detailed maps of where the dark matter is surrounding various galaxies. And like, you just can't you can't wish this stuff away now in the way
Right.
that I think people could in the past and just go, well, you just don't understand gravity. Well, why does the gravity of this galaxy behave differently than the galaxy of that galaxy, the gravity of that galaxy, when they're roughly the same size? And also, you can see the indexings. You can see how the light is being distorted as it's passing. Yeah, there are dwarf galaxies with very little dark matter, and then there are blobs of dark matter with very little galaxy in them, and
Right, right.
everything in between. This was a big surprise. Like, this is just the last couple of years they've really started to make these observations.
There had been a few isolated papers going all the way back to the early 2000s of looking at this particular dwarf galaxy. It looks like it has a massive dark matter to luminous matter ratio, but it was just isolated papers, and it's only through one isolated paper at a time that we're able to build up this. Yeah, looking at the entire thing, it's a diverse family out there.
Yeah. Yeah, really interesting. All right. Well, thank you, Pamela.
Thank you, Fraser. And thank you to all of our Patreons out there. Without you, we would not, well, we would not be able to do what we do. We would not be able to pay Nancy, Rich, Allie, Beth, all of the wonderful humans that make this possible. And this week, I would like to thank Thomas Sepstrop, Mountain Goat, Stephen Veit, Burry Gowen, Gordon Young, Jeanette Wink, Kevin Lyle, Andrew Poelstra, Venkatesh Chary, Brian Cagle, David Truog, TheGiantNothing, Will Hamilton, Aurora Lipper, David, Gerhard Schwarzer, Ronald McCoy, JF Rogette, Kakawa Sarif, William Krause, Robert Plasma, Laurie Kettleson, Joshua Pearson, Les Howard, Jack Mudge, Joe Holstein, Gordon Dewis, Frank Tippin, Neuter Dude, Adam Nice Brown, Helga Bjorkog, Richard Drum, Alexis, Wanderer M101, William Bacher, Zero Chill, William Andrews, Andy Cowley, Jeff Collins. So if you would like to have me mispronounce your name, as Fraser described it last week, please consider supporting our show over at patreon.com/astronomycast. You make the science flow.
Thanks, Pamela. All right. We'll see you next week.
See you next week. Bye-bye. All right. And then they saved.
6:34.
So how did you guys do with the giant river of water that came through, according to meteorologists?
Which one?
The one last week.
Oh, fine here.
Okay.
Yeah. Yeah, no problem. We got a little rain. Wasn't bad at all.
Cool.
We actually got some more snow, but then the snow went away again. So, yeah, no, it's these rivers, these atmospheric rivers are very targeted. They're 50 kilometers wide and come in and hit. They tend to, bunch up against the mountains, or get focused in places like sort of around Vancouver. There's like mountains that sort of act like a triangle around Vancouver and focus bad weather systems down near the end. Like, in November and stuff, we had all of those, all that horrible flooding, and all of those highways get destroyed and so on. But haven't anything so far. It wasn't anywhere near as bad as it was back in the fall. No, I think now we're through that, and now we get to look at the summertime environmental disasters like the heat waves and the wildfires.
Yeah, we had tornadoes in the region last night.
In the middle of it. It's crazy.
Yeah, it's too early for that.
Yeah. All right, we got a couple of questions. Hal McCann asks, if using a galaxy to gravitationally lens a more distant galaxy, how do you know how much distant galaxy is getting magnified?
So you can work out, it's basically a lens equation. you can work out the galaxy in the middle has a specific distribution of mass. All the light from the background galaxy is going to have gone near that foreground galaxy and gotten bent towards us in a way that is directly related to the distribution of mass in that middle galaxy. So it's as though you had a really lumpy, bad lens that is changing the light from behind and causing it to be distorted, but it actually gets to us, which normally it wouldn't do. So we're happy with the distortions. But it's not a matter of some of the light. It's simply a matter of everything gets bent our direction in a distorted manner.
Right. Time of Dying 00 says, how do the bars of the bar spiral galaxies form?
We're still trying to figure that out.
That's still another mystery.
Yeah, we do know it has to do with interactions. So our galaxy, for instance, appears to be a barred spiral, and we're interacting with large and small Magellanic Clouds. Other galaxies that we look at that have bars all have companions. So it seems that both grand design spirals and barred spirals have their structure influenced by neighbors.
It's a weird thing, the bar.
Yeah. Oh, yeah.
It's so weird because you have this literally a bar that passes through the core of the galaxy, and then the spiral arms go right angles off of this bar and then spiral outward. And it's you would think that the spirals would start right down in the middle, and why they don't is still a bit of a mystery.
So over on Twitch, we have Rams Reeve first commenting that the drink looks good, and I have to plug Amy Davis Roth, Surly Amy. Retro Ceramics is the reason I have this mug of awesomeness.
Oh, she made you a whole mug.
She did.
Cool.
It's spacey, and I basically said I need a 20-ounce mug, and she made one. Richard Drum then goes, how's the house construction going? It's spring. Are you going to have a house faster?
Oh yeah. We're probably about a month away now. So
That's awesome.
We just had the floor polished because it's concrete. It's concrete floor. The drywall is going up this week. All the electrics are in. All the plumbing is in, but not finished. They're going to have switches and stuff.
Yeah.
The siding is on. We're getting the water pump set up probably this week, next week. So we're starting to move into the more finishing stuff, getting the cabinetry put in so we can have a kitchen. I think, by early to mid-April, we should be in the new studio.
That is awesome.
Yeah.
And broken.
So not a house, but a studio. We're living in a studio.
It's a 2-part process for you.
Yes. Yeah. But the studio will be my forever studio. So once it's built, then it will be the place that I work in day out for the rest of my life.
Yeah, and what I'm hoping is you can have your studio up and running so I can redo my studio.
Right.
Because we're going to bring in some construction folks to redo this room, make it so I can mount lights and the ceiling no longer falls in small chunks of plaster.
Right.
But Broken Symmetry almost made me snort with a comment. How the bars formed in galaxies important, but even more so, do they serve pan-galactic gargle blasters? Fraser, do you know the answer to this?
Do I know how?
Do you know if they serve?
Blasters?
Do they? Can I go order one?
I don't know. It all depends on whether the Hitchhiker's Guide to the Galaxy can be trusted. Annelcert asks, we know Pamela doesn't want to talk about new hardware before it becomes operational, but when are we getting a James Webb episode? We just had one. We broke all of our rules.
We did.
And we had a James Webb episode.
And last week I put together the schedule for the rest of the year out through summer hiatus. And let me pull up the exact date. We are going to have episode 650 is Did It Work?
That'll be the James Webb episode.
Well, so it's SLS, Starship, JWST, Blue Origin, all the things that like we've been promised that between now and July 11 are going to work.
Yeah, Artemis 1 should launch by then.
Well, that's SLS.
Starship.
Yeah.
Yeah.
So,
there's a lot of big. Vera Rubin.
That one I'm less worried about by July. I think they're looking at more of an August, September.
Okay.
But it's on the ground. I'm not worried.
Yeah, there's a lot of big events clustered in the next couple of months that are supposed to happen.
And this episode, I have to say, is entirely inspired by a Kate McKinnon cold open on Saturday Night Live, where she was like, "Does it work?" And the answer was over and over, no. It does not work. So look up that sketch if you want to understand the inspiration for this particular episode, which will be the last of the season.
That's awesome. Hal McKinney asks, is the bar direction relative to the supermassive black hole quasar direction?
They're orthogonal to each other. Jet goes up, bar goes across. Disk of galaxy goes across.
Right. Because, like, in general, the rotation axis of the supermassive black hole matches the rotational axis of the galaxy that it's inside.
So the thing to think about is, so I'm resorting to, like, can this be seen? Yes, it can be seen.
Yep.
So wire tie science time, people. The jet is driven by the physics of the stuff that rotates around it. So the bar is a moving target that goes around and remains at 90 degrees to the jet.
Right. And it would be more accurate if you were spinning the vertical one as well, but, you know.
I lack that coordination.
At relativistic speeds.
I lack that coordination.
Would be ideal. Yeah. That's it. Those are all the questions that we've got. Do you have any questions over on Twitch?
No, that's about it.
So did you see the I'm going to swear, the batshit crazy video that the Roscosmos released of the International Space Station?
Yeah. And have you seen the so I have so many feels about this. It's like when a really little kid does something really bad and you have to laugh, but you know it was wrong. So Scott Kelly is out there egging on Rogozin in Russian to the point where Rogozin is basically like, do you want us to drop the ISS on you? This will be your fault. And
what a baby. Yeah. So they released, and for people who haven't seen it, like, give a search for it. They released a video where, you know, they took some clips of the Russians and the Americans inside the space station, and then they matched it up with some simulated video of the Russian portion disconnecting from the space station and flying off to great adventure.
Yeah. And it doesn't have the ability to power itself. It's solar panels are not good enough for that.
Yeah, they're just taking their toys and they're going home. And it was crazy. Like a temper tantrum. I couldn't believe it. So yeah. And, you know, I think I mentioned this last week that Rogozin has changed his Twitter icon, his Twitter background to be nuclear ICBMs.
Yeah.
So
our daily space episode, and I'm super proud of our entire team.
Yeah, how did that go?
It went really well. I'm super proud of the entire team of writers that worked on it. We aired it Friday. It's up on YouTube right now. Let me see if I can grab a link. And it aired this weekend on Now Media TV as a special. It's one of these things where we went through and we looked piece by piece at all the different things that are essentially being impacted. And there's a lot of things I didn't know about. So like Venera D evicted all of the NASA instruments. So then there's the obvious ExoMars probably isn't going to launch this year.
Yep.
But like Cygnus, I hadn't realized how bad Cygnus would be. I'm going to drop you the link to stick in YouTube, Fraser. It's in the rendezvous chat.
Okay.
So the Cygnus rocket is designed so it can either launch on its normal rocket, which unfortunately has tanks built in the Ukraine in a facility that I think I saw destroyed video of this morning.
Right.
And its engines come from Russia. So it's not launching on that one after the next.
Yep.
I believe they have 2 more launches they can do.
Yeah.
Cygnus can also launch on the Atlas V, but all remaining Atlas Vs are already sold. So we're looking at about 2 years to be able to figure out how to launch the Cygnus on something else, best guess. And currently the Cygnus and the Soyuz capsules, or the Russian capsules, Progress rather, are the only ways that we have to boost the International Space Station as its orbit slowly degrades. And it's safe for about 2 years. Now, the reason that we can't do it with the Dragon capsule, which everyone's been asking, is the Dragon capsule and the Cygnus are both designed so that their thrust comes out at an angle so that they don't vaporize their trunks,
Right.
which is useful. But Cygnus has a gimbal that allows it to redirect those thrusters, and the Dragon capsules don't have that gimbal. So the question becomes, is it easier to reconfigure Cygnus to launch on something else like the Falcon 9, or to reconfigure the Dragon capsule to
Right.
have those gimbals? Something's going to have to get figured out, or, I mean, right now it's looking more and more like the ISS is just not... That was part of my ceiling.
Speaking of,
So,
yeah,
big old chunk of plaster stating its opinions.
that's funny.
Yeah, yeah,
If it wasn't also a little unnerving and frustrating.
yeah. So, I'm looking forward to having, like, in my dream universe, I have a lath and plaster ceiling in here right now that was put up in 1893 and has had holes put through it for all manner of different cables and pipes and termite treatments. And so the plaster is no longer stable and just falls in chunks off the lath. And I want all the lath, all the plaster removed.
Yeah.
And the only reason I haven't done this myself is the gas pipe. I don't like to die. So we're going to pay someone to remove all of that. And I just want them to put up like wainscoting or nice wood that I can drive screws into. This is my goal. Anyways, I have thoughts.
Dwayne Duvall asks, do stellar mass black holes move towards galactic centers like supermassive black holes, or do they just do their normal stellar-like thing?
They do their normal stellar-like thing. Supermassive black holes are in the centers of galaxies pretty much because they form there. And they end up there during mergers because the 2 supermassive black holes are sitting in the center of mass, essentially. So it's not so much that they move there as they and the galaxy around them grew together.
Right, right. Okay. I don't see any more questions on YouTube. Do you have any more questions on Twitch?
That's what I'm trying to figure out. So, no, those are all statements. I'm being told to not be afraid of my gas pipe because there is a shutoff. I am going to be afraid of it if I want to be afraid of it. I feel that is safer.
Yeah. Yeah, our trailer is heated by natural gas, and even though we've got a carbon monoxide filter in it, I'm always paranoid that I'm going to die of carbon monoxide asphyxiation.
Yeah, yeah.
So.
Yeah, we have a gas boiler, gas water heater and gas dryer. And ironically, despite the fact that the gas line goes directly under the stove is electric. And I think it's because we looked into replacing the stove, and because of the geometry of where the downdraft air thingy is, it is thousands of dollars to get.
Right. Yeah.
Yeah, so we have an electric one.
Chris G asks, how many more months do you think before we get some groundbreaking images from James Webb? 3.
So I'm going to go with before our July 11.
Yeah. Yeah. Mid-June.
Episode.
I would say sometime in June.
Yeah.
Okay. All right. Well, I am going to wrap things up then. So, yes. Pamela, thank you so much for hanging out today, doing this episode, braving a literal ceiling that's falling down on top of you. Thank you everyone for watching, both on YouTube and on Twitch. Thanks to all of the moderators for keeping things organized. Really appreciate it.
Yeah.
And we will see all of you next week.
Bye, everyone.
Thanks, everyone.
And hold on. Awkward transition.